The topic for today, we're going to go through Subgraph best practices 1 through 6. There's two more best practices that have just been put into the docs literally a few minutes ago. It's actually in staging, and I was hoping to get it to production by the time this presentation went through, but it's almost there. So we'll hopefully have that by the end of the day into production. But before we do that, what I want to say is two quick announcements, and I'll put this in chat as well, are of course, a lot of feedback that the graph is hungry for right now. The graph, if you don't know right now, is, well, with Sunrise being such a success, and now we have a new direction that the graph is going to be heading in the coming years. So we want to reach out to a lot of people and get feedback, get feedback, get feedback. So that's a really big part of this. So if anyone watching here would like to share feedback about the graph and kind of shape the direction of where the graph, where you'd like the graph to go, let's hear it. Let's hear where you'd like the graph to go, because we want to know what your thoughts are. We want to know your critiques. We want to know what you like, what you don't like. All of those things matter to us. And so if you're able to fill out that survey that I just linked in chat, that would be awesome. I'll also link it into the Twitter right now, where we're going to be able to look at your guys' thoughts and look at your guys' feelings. And from there, we can build better. So I'm going to put that into the Twitter as well. Please fill this out. That would be awesome, because essentially, we're building decentralized infrastructure every day, and we want to know what you guys think. That's really important. Also, yes, the GRC20 feedback in the forum, let me actually put that in chat too, for the GRC knowledge graph from Yaniv. That was last week. That's a big deal. That's a really big deal. So I'm dropping that in the chat, as well as I'm dropping that on Twitter. Please drop your feedback. Please share feedback on GRC as well. Both of those things are super important, and they lay a foundation. Your feedback lays a foundation, and also feedback on GRC20 lays a foundation for the future of the graph. And we want to build the best we possibly can, and working with Edge and Node and all the core dev teams, we're all very much focused on doing right for this protocol. So please, please, please let us know your thoughts, let us know your feelings, and we'll get those to the project managers, get those to the different team members. That's a really big deal for us. So that is it for the announcements today. If anyone has any questions with this presentation, I've got chat right over here, and I'm going to be presenting this screen right here, so feel free to drop the chat. Some of this will be a review, because I've already done subgraph optimizations 1 through 4, and we're going to go through those again just to have everything in one video, because this is, of course, being recorded. And the new ones we have come from a few different PMs and also from developers of GraphNode itself. And these are things they recommend to be added to the list of subgraph best practices. So we'll go over those at the end, and then just know there's a few more also best practices that I'm continuously talking with people who are building GraphNode specifically and seeing what is best for the entire experience. So let's get into it right now. Let me share my screen. There we go. Okay. Okay, are we good to see my screen? Yes, yes, yes. I think we can see my screen. I'm seeing Discord seeing my screen, so that's a good thing. So right now, for those of you who just want to get to the point of this, we don't have to go through the full presentation. Subgraph best practice 1 through 6 are in the docs, and they are in staging right now, and they should be pushed to production very soon. So check later today, but go to Cookbook and you will see Subgraph best practice 1, 2, 3, 4, 5, and 6. And that provides written documentation for each of these, and we're going to go over each of these in a more visual workshop type of way. However, if you just simply want to go through these and learn quickly, go ahead, hop into these 6 best practices and learn them, so you can take that next step after deploying your first subgraph to learn how to optimize these dang things, make them the best they can be. So that's subgraph best practice 1 through 6. 1 through 4 are already fully in production. 5 and 6 will be there very soon. So here we go, subgraph best practices 1 through 6. So for all of you out there that, let's see if this is able to be seen. Yes, we're good. How to optimize indexing and querying speed. Essentially, each of these best practices either and and or optimize indexing and or optimize query speed, which is really the fundamental part of interacting with subgraphs. You need to have faster indexing or faster returns of data. And so let's go through that real quick. If anyone here is not subscribed to the Graph Builders newsletter, I write this every month for builders in this ecosystem to just be aware of any news and updates. So please scan that if you haven't already and join the newsletter. Let's keep on going. So I like starting with quotes. So let's go ahead and do that. Success is the sum of small efforts repeated day in and day out. I look at subgraph best practices as just that. There's small little changes that can be made to subgraphs, and they can have demonstratively huge results in performance improvements. I, for fun, built a subgraph worst practices subgraph that used the opposite of subgraph best practices, and I saw a 50 to 60 reduction in just indexing speed and query responsiveness. It was not good at all. So don't do that. Do the best practices if possible. And quick review for anyone here who is new to subgraphs. The subgraph itself has a database inside of it. It has a PostgreSQL database. And within that database, if that size is huge, that is just more data to manage. And if it's smaller, that's less data to manage. And that's an optimization point about a lot of these best practices that are important. And so if we can keep those tiny, that's a good thing. And then also the processing of the subgraph. If we're able to optimize processing and have that data just rapidly go through the subgraph as opposed to a little bit slower, that's also going to be something that we look to improve on with subgraph performance. So looking at that database size and then also the processing speed. Every one of these will affect either one or both of those. So just know that moving forward. The first best practice is indexer hints. It's pruning a subgraph with indexer hints. Now, essentially what is pruning? Pruning is taking that database from this big and making it this big. Essentially just making it smaller, and that makes it much lighter to index and much lighter for it to actually find data. And so if you actually are going to take that database size and make it smaller, you're going to have faster query response times because just running through that data, it's going to be much faster. And happy indexers. I mean, when you have an indexer, if there's any indexers in the audience, you might be able to vouch for this. Smaller subgraphs are just easier to manage, easier to retrieve data, easier just to have on your systems. So that's a big deal. And how to use indexer hints, it's very easy. The recommended way is just to leave this default in the schema. This is subgraph.yaml, and you'll see if you spin up a subgraph today, a new subgraph, the older subgraphs don't have this because this is a relative new feature, but if you spin up a new subgraph, you'll see indexer hints prune auto. And what that will do is prune a select amount of blocks data that are in the past as dictated by the indexer. So whoever's indexing that gets to dictate the amount of data that each subgraph will hold. Now, if you need to actually have specific amounts of data stored into your database, then use a prune number of blocks to retain. So what you'll actually do is say, hey, I want 1 million blocks in the past to always be within the subgraph. Well, you can do that with just simply putting a number right in there, and that provides a little bit more control on your end. And also, if you don't want to prune ever and you just want to have everything always there, just simply put prune never. Just using that is going to be huge for optimization, just having a smaller database size. This is a big one. This is actually number one for a reason. This was encouraged by the GraphNode team to be the number one. So use this one if you haven't used it already and make your query responsiveness super fast. So considerations, of course, before pruning, because you are removing data from a database, there's things to consider before you do this. If you're using time travel queries, that is queries that are looking at past data from a significantly, from any amount of time that might be removed, once it's been proved, you can't get that data back. So be specific. Use prune number of blocks to retain or prune never, never, never. And then there's grafting. If you want to graft onto a block height that has been pruned, well, you can't do it because that hasn't been indexed. So be specific if you're going to be using grafting. Those are things you just be aware of if you're removing data from that database. Let's go into the second best practice. This is use derived from to manage arrays. So as with databases, if you have copied data in two different locations, duplicate data, that's just bloat, and that is going to be slowing down performance big time. So derived from is a big part of allowing that duplication potential when you have multiple arrays to just go away. So at least when you're using derived from properly. So when you are using derived from, you're not going to be having database bloat due to duplicate data entry. You're going to have faster query response times, faster indexing speed, and once again, smaller subgraph database because you're not having duplicate data. So if you don't know how to use derived from, that's okay. These right here, whenever you see an array in anyone's schema, just say, hey, could this be a derived from? Just I always look at arrays in a schema and say, hey, is it possible that we could do some linking there? And sometimes no, but if it's possible, do so. In this instance here, we have a comment. We have a field that says comments, and it's an array of comment. And that is going to be, in this instance, doubly. We're going to have double data entry in this instance. So instead, what we make this into is a derived from. So now we do not have double data entry into our database and things can stay lean. So that's really important for just having better performance of our subgraphs. So if you don't know how to use these, of course, go to the docs and go to those cookbooks and you can read more on derived from. There's a few other things that are unlocked with use of derived from. If you are doing reverse lookups, that's really nice. So typically you're looking at a post and all of its comments. Well, what if you want to look at a comment and see which post it comes from? You can actually do that with derived from because that linking is in there. And then also it unlocks another more advanced feature called derived field loaders, where essentially when you have those relationships built, it creates a virtual relationship. And that is in a database within itself. It's in its own little area of the database. And you can actually pull data in from that linking. And that's called derived field loaders. A little bit more of an advanced technique, but derived from unlocks that potential where you can see that. So play with that if you haven't had a chance already. If you're a little bit more advanced, check out derived field loaders. And there's a wonderful, more deep dive with derived from Kevin Jones, the other DevRel here at Edge and Node, and he went in deep into derived from because this is, I'm trying to keep this relatively simple, but this of course goes deep. So go ahead and check out this blog post if you really want to master the derived from technique, which is super, super powerful to use when building. So next, subgraph best practice number 3, using bytes as IDs as well as immutable entities. Now, these are two kind of different features themselves. However, both are super critical in terms of just making processing go so much faster. So let's talk about that. Essentially, when you have an ID, if you have a lower level type, such as bytes, that's way, way, way easier for indexers to process. And also immutable entity. Essentially, if you have an entity that you mark as immutable, that's way, way, way easier for a database to process, an indexer to process. So both of these, if you combine them, you could have up to a 48% improvement in indexing speed, which is crazy, as well as improved query responsiveness, 28% improvement. Now that's using these in conjunction. This is based off of testing from David Lutter, who is one of the GraphNode engineers, and he did some tests on his own with this. So this is really powerful. If you're using other things for IDs, right here, the entity right here that's not using bytes as an ID, it's using just an ID, which is a string actually as ID, the type. And it's also not an immutable entity. There's reasons to make not things that are not immutable and reasons to make IDs as strings. Wherever possible, try to have the IDs be immutable, and that means you don't change them in the future. They're just immutable. And also, wherever possible, try to have your IDs be bytes. And if you need a string identifier somewhere, try to make it another field in the entity as opposed to having it be the actual ID. Just leave it as bytes. That's a huge, huge performance increase right there. So I took that transfer entity and just converted it to something that is happy, where the immutability is true and the ID is bytes. So those little lines of code make a huge, huge difference in performance. A little thing right here. This is baked into the CLI as you're building. However, if you have an older version of the CLI, not the older version of CLI, but an older subgraph with old information in it, just update if you can the graph TS, and then from there you'll be able to use this. The concat I32, it allows a concatenation, which is really cool if you're looking for a quite random, if you will, bit of information for the ID. And this is the transaction hash and the log index. And you can concatenate those two with this little method. And then from there, it returns bytes. So this is a really good way to create IDs that is nearly random. I'm not going to say it's random because random is tough, but it's damn good for IDs. And then from here, using bytes as IDs and mutable entities. Also, sorting by bytes is problematic if you want to do that because it's bytes. So what's recommended is, like I said, make another entity, make another field in the entity, such as token ID. And then from there, if you're doing that as a counter, you're able to have better sorting. So yeah, try not to use an ID beyond just identifying a entity and just simply build out the entity with a little bit more thought in terms of if you want to organize things, and that goes a long way. So reasons to not use bytes as IDs and immutable entities. If you need human readable IDs, and that's required, let's say you're taking a Postgres SQL database and you have to merge that with another, and the other one is using strings as IDs, then, well, that's what we got to do. And then also performance improvements are just not desired. You're just hacking around and just having some fun. You don't need to. But the second you go into production, I would highly recommend that. So this is an article, once again, based on David Lettercourt, and he wrote this a little while ago, and it still is holding true, and it's very strong. So that's all. Another one, avoiding ETH calls. If anyone here has used an ETH call, what you're doing with that ETH call is sending out a call, and that's not going to the subgraph. That's actually going to an Ethereum node or whatever, EVM compatible chain node is out there and getting that data back from there. So you're relying on infrastructure that is not the subgraph. And when you do that, things can, get a little funky. So essentially, this is a visual showing what happens here. We want that data to actually get into this database, but to actually get into the database, we have to rely on this node. And is that going to be fast? Is it slow? It's just not great. So we want to avoid, if possible, ETH calls just because we're relying on outside infrastructure. And it can absolutely improve indexing speed, and just indexing overall is highly optimized. Now, if you want to find where an ETH call might be in a subgraph that's already out there, just look for a bind. Just do a Command F or Control F, just find the word bind, and that's going to let you know that there's very likely going to be an ETH call coming up right after that. And so you can see it on this one right here. There's a demo of where you see a bind, and then you see that being called later. So if you are unable to avoid ETH calls, let's say you're not developing the smart contract and you need to actually do ETH calls, look at using declared ETH calls. Now, this just came out recently, and I'm actually going to do a little video on this coming out soon. So go use this. This does improve the performance of ETH calls. So if you're currently using ETH calls or just wanting to expose yourself to ETH calls and kind of how to handle them, check out declarative ETH calls. And that does allow for better performance. Although it still slows things down a little bit, it is better. This is another blog entry right here from Simon, and he wrote this really just going about the best way to deal with this interaction with another part of blockchain infrastructure, which is going to other nodes that are not in the graph and getting the data. So how do you manage this? He goes into a few different strategies that are quite good. So this is a new subgraph best practice, time series and aggregations. I just built a subgraph a few days ago using this, and it was super fun, super easy, and we'll go over this right now. So why is using time series and aggregations a subgraph best practice, a new one? Essentially, it allows for better responsiveness with queries when you're sending a query, because you're not dealing with the mappings. You're just going to the database itself, and the database has baked in ability to do compute. You're just going to the schema. And so just by doing that, it takes processing and puts it just one location as opposed to two, or splitting it up, I guess. I'm not a graph node engineer, but at the same time, keeping the compute in the actual schema is much more performant than having it actually go into the mapping. So that's a big deal. And that is going to have indexers be happier as well. So how do we go ahead and use this? Once again, right now, if you saw that video I made the other day, great. And if not, that's okay. The feature is experimental right now. It's still being rolled out, but it's so powerful, it already is a best practice. Let's go over this really quickly on how to do this. Essentially, you need to create a time series entity, and this entity is going to be responsible for gathering all the data. And the requirements on this entity is it must have an ID of int8 and it must have a timestamp of timestamp. These are the two required things that are fields that must be there. And then there must be the data that you're trying to gather. And this is the price. And this is the information that we will eventually be doing processing on. I look at this like I use slang here. I look at this like a bucket. We just need as much as we possibly can get in there to then do processing on. And then how do we do the processing? We actually go into this entity. This is an aggregation entity. And in this entity, we can identify how often we want to do processing. Do we want to do it every hour? Do we want to do it every day? And then where are we getting this data from? We're getting it from data, which is this entity here. So super easy to set this up. This also, of course, needs an ID and timestamp. The ID must be int8 and the timestamp must be timestamp. And then here we can begin the calculations. So this is just a field called sum. And as you can see here, we're doing a sum calculation on the price right there. So this will sum every hour and every day with that calculation. Super cool. So there are many other ways to do aggregations. I think of aggregations as calculations. And you could actually use SQL, and you could do many more different expressions with these aggregations. And go ahead and go through the docs and here, look through the GitHub and see all the different ways that you could do calculations and actually do a little bit of filtering with this. It's really, really, really powerful with this as well. So that is awesome. So let's go ahead and go to the next one, which is subgraph best practice number 6, is using grafting for hot fixes. So who here has deployed a smart contract? You could raise a hands that you thought was the last smart contract you'd be deploying. You've got it indexed with a subgraph, and then from there, you're like, oh, dang, I've got to make a change to the smart contract. And then, oh, dang, I've got to go ahead and make a change to the subgraph then. Oh, dang, well, I've got to catch that subgraph up and reindex everything. Essentially, grafting allows for the ability to make sure that previously indexed subgraphs data is preserved, and any changes that you need to make on that following subgraph simply tack on to what's already been preserved. So that is a really big feature if you don't use this day to day. Grafting for hot fixes, let's say there's a subgraph with errors. Also, let's say if you have any smart contracts that are updated and a new address, and you have to get that information too, and you want to combine that with a subgraph that already has lots of information. That's great. Let's say also you want to have a subgraph itself that has new features that you want to do, and you don't want to reindex from the very beginning. That's another reason. Just getting skilled with grafting for hotfixes, be it new smart contract address, or maybe there's an error in the subgraph itself, and you've had a lot of data in that subgraph, and you don't want to wait anymore. This is a really good technique. So how do you do that? Let's say you have a subgraph right here, and the start block is at 5,000 right here. And you say, hey, I want to graft on this data. I don't want to lose the data of this old subgraph. How do I not lose this data and just continue on from the last block that I'm interested in? Well, what we can do, we'll zoom in here. Zoom in for the viewers. Let's say we want to build up a new subgraph. So we'll build a new subgraph right here, and we look at let's say hypothetically we have a new smart contract right here, and we've made updates to the smart contract. Cool. Well, we'll put a new smart contract address in there, and then the block that we are interested in, basically the block after the last indexed block that we want to take a look at. So that'll be 60001. And then we will graft on the old subgraphs right here. And all we have to do is put the features grafting, and then also put the deployment ID of that older subgraph and the block of the last successfully indexed block right here. So going back, just to review, let's say we are at this subgraph. This is our old subgraph. Let's say maybe there's an error on this subgraph, or we have a new smart contract. There's lots of different reasons why. This is an old subgraph that we want to update and we want to preserve the data. Cool. We have the start block at 5000000. Let's look at the new subgraph, and we'll say, hey, it's been indexed from 5000000 all the way up to 6000000. And so we want to preserve that data and then continue at 6000001 and then continue on. So that's grafting. That's a big deal, and I would say that's a good skill and a good best practice to have. If anyone here hasn't used grafting, just think of it as you are needing a change and you want to preserve the data and then continue on from there. So that is subgraph best practice 1 through 6. There will be more. I'm working on subgraph best practice number 7 right now, actually, and I think we're considering a number 8. And I look to update this video every 6 months, every year or so, and that's about when I did the last one. So stay tuned for more best practices and really having that experience be as beneficial as possible when building. And really, once you deploy your first subgraph, in my opinion, learning these best practices should be the next thing that is done because they teach the techniques that have the most bang for the buck in terms of having performance be top tier for the length of your subgraph development career, be it one day or the rest of your development journey. So learning these is a big deal. For those of you joining right now, please sign up to the Graph Builders newsletter. This is where I write news that is developer focused for builders in this ecosystem. So please hop into that. And with that being said, let's go into questions. Let's look in the chat here. If anyone has any questions, feel free to ask right now. Let's see. For indexers, grafting is not automated. Yes, so there's some context here. Thank you about indexing for grafting with production subgraphs on the graph network that are decentralized. And so for indexers, grafting is not automated. So new versions need to be published on Discord to make sure indexers deploy the new version. Nice catch. It also poses a problem where the old deployments stay in database and the new deployment copy over all old data to keep the new deployment. So indexers can delete or keep the old deployments for future uses. If there's anything clarifying that should be said right now, if any indexers are out there and want to add more clarifying information on grafting, please share, because this is the time to share that. And yeah, great ping right there. I'll be sure to update the slides and documentation with that. Really good catch. And would be awesome to have a similar thing for substreams. I agree. I think there could be a substreams best practice series as well. So when that time comes, that will happen. I think that's a really good idea. So for now, if I don't see any other questions, it makes me feel good that may have arisen or maybe answered by the presentation. For now, I'll say thank you so much for joining me on this episode of Graph Builders Office Hours. If you have any questions, I'm on X or Twitter. Find me there. And if there's anyone out there also that missed the beginning, please go ahead and do the feedback that I put in the chat as well as I put on Twitter. There's feedback we're looking for GRC20, and there's feedback that we're looking for the graph as a whole. And there are 2 big points of feedback that we would absolutely love to get from builders in the ecosystem, whether you are just a beginner subgraph developer or advanced substreams powered subgraph developer. We want to hear from you about how you are building and things that we can do to improve your experience. So, okay, everyone, have a good rest of your day. I will go ahead and close here. Another announcement, we're not going to be having a builders office hours next week or the next 2 weeks, because it's the holidays out here. And let me stop sharing my screen. There we go. Because of the holidays, and I'm the host of Graph Builders Office Hours, and it's been difficult to get a few different guests coming up on here because people are traveling or people are doing holidays. So we're just going to call it and not have the next 2 weeks of episodes. With all that being said, thank you so much for everyone's time today, and I wish everyone happy building and happy holidays, and look forward to seeing y'all on the following new year. So happy New Year, everyone. Take care, everybody.